Hello and welcome to our second video of chemistry or CHM 117, and today we're gonna discuss about the chapter which is about atoms, molecules and ions. So let's begin. So our first topic is about atomic structure. So we all know what is atom. Atom is the smallest unit or bit of any substance or matter. So a atom has three parts on it. First part is proton and there is neutron, and this whole region called nucleus, and there's another layer, or it is called shell, which is called power shell, and and the number of shell varies according to the atom. Some atom might have three shell, some might have four shell, according to the atom size or electron size. Those shell matters increase or decrease. In the cells, there are electron. There are electron lives inside those shell. So this is a typical structure of an atom, where the electron moves around the nucleus, and nucleus have proton and neutron. And there's another thing: proton is positively charged, electron is negatively charged, and neutron has no charge, or it's a chargeless. And this is the atomic structure, or you can say how an atom looks like. Next one is atomic number. So there are some terms we have to know in terms of begin this chapter. First term is atomic number. What is atomic number? Atomic number is basically the number of proton an atom has, called the atomic number. And the atomic mass, or you can say ATM here, is just the summation of proton, and the mass unit is gram per mole. Mass unit is gram per mole. For example, in your periodic table you will see just like carbon. Here carbon, and here is, so in periodic table there are 180 atoms in the whole world, or you can say they are discovered. And in periodic table you will see the classification or detailed version or detailed structure of. In the periodic table they have written in this form. Sometimes they have some gram here, which denotes the gram, but we are, because our main concern is here. So here the upper side, the atomic mass, or you can say combination of proton and neutron, and this one number of electron. Okay, to find the neutron, or it's not of electron, it's number of proton. Yeah, this is the number of proton. So find the neutron number. What we have to do is just we have to subtract atomic mass ATM from the proton number of proton. That means this 6. What we get is the answer is the number of nucleus or neutron, number of neutron that atom has. Okay, those are the some terms, and in exam a faculty will give us something like, they will give us this option 12 and 6, and tell us to find the electron number, of neutron number, of proton number. Those type of question gonna arise in our. I have skipped one thing, which is in a couple of minutes ago or seconds ago, have you heard about the atom structure, which was look like. So this is the nucleus, and around nucleus electron rotates. But the main question arises here, that how many electron rotates here. As you know from that from the previous one, for example 6 and 12, there from this information what we get is that the neutron number of n, we subtract 12 from 6, the proton number also. There are another thing that I want to say, that in a stable format such as this format, the number of proton is equals to number of electrons, so the electron number should be same. In this partial shell there will be 6 electrons, but we don't know in each cell how many electrons should be. There is a formula that will tell us that in a particular shell how many electrons should be there. The formula is like this: 2 n square, where n is the cell number and rest of the is the constant value. For example, if the n is 1, what will be the result? 2 into 1 square means 2. So we can say that in this first cell, 2 electrons can be floated in this cell. What about the second cell? This cell will get 2, so about 4 into 2. 8. In second cell, we can have 8 electrons floated in this cell. So this is how we can construct or make a atomic structure of any atom with the help of this information as well as the 2n square. Know in how much layer in each shell. Okay, so each cell are mainly there are lots of shell, but mainly we talk about the 4 shell, which is known as SPDF. K element, which are known as K element. The first shell is called K, second L, M, and the last cell is known as N cell. Talk about them later on our video. Now, electron, we was talking about the electron or atom. In our nature, it is possible or it happens that electron has same number of neutrons, same number of proton, or sometimes they have same number of electron as well. These atoms are called isotopes, isobar, or isotons. Let's talk about one by one. With isotopes. Isotopes means there are some electrons, more than one electrons, having different neutron numbers, different, but proton number and electron number are same. Those two values are same, but the neutron number is different. This type of polar atoms are called as isotopes because their neutrons are same. For example, carbon 12, carbon 6, and carbon 312. Here, electron numbers are same as proton number because they are stable form. The neutron numbers are different. In that case, two will be known as isotopes. The neutrons numbers are not same. We have another one called isobar. We have another types of isobar. Isobar, what to say? Their mass will be same. So means same, and bar means heavy, those mass. So those types of argon, for example, argon's weight atomic number is 40. So potassium also have 40. Their atomic mass are same. So that's why they are called as isobars. Last one, especially three categories to similarity. First one is isotones. The what the neutron numbers are same, Detroit. What isotones? In isotones, neutron numbers are same, atomic mass, the atomic number, you can say proton number, are different. Atomic mass and proton number are different, but their neutron number are same. Examples are C, carbon 40, carbon 40, neutron. Neutron numbers are same. Neutron numbers same, but rest of the things are not same. Those types of similarities are called isotons. Let's go to math. You can say calculate the relative molecular mass. Molecular mass is the total mass of a molecule. You know, every atom has their individual mass. Their molecular should so molecular also have a mass. I'm gonna find out the mass. I've given a math without molecular for ammonia. You can see the molecular formula is ammonia only, ammonium sulfate, NH42SO4. To calculate the mass of an atom, what we have to need is that multiply between the number of atoms and their weight or their mass. For example, here the number of N or nitrogens are 2 nitrogen atoms, so their total mass of one nitrogen atom mass is 14, so there is two total mass will be 28. Hydrogen has four atoms, for example 4 and 2, well it means 8 atoms. If you just multiply with 4 and 2, then we'll get 8 hydrogen atom, and the hydrogen mass is 1. So um, um, the total mass of that hydrogen is 8 sulfate, and next is oxygen. And after calculating each of their mass individually, calculating them, we just have to add those things. So what we get at the end is the total molecular mass. At the end you can see argon, there's an is a electron given, argon 187. In an exam we just have to find the four things: proton, electron, neutron, atomic number, and atomic mass. On next page is another math you have to do in this chapter. It is finding out how much specific atom present in a particular molecule. In the previous math, what we have calculated is that the whole mass of an molecule. But in this math, we're gonna find a particular atom, how much atom is in it, a particular molecule. So to find that one, we just have to find the relative molecular, or you can say the total molecular mass. We have to find it out. Then one by one, we have to find out how much percentage of mass are there in the volume. It's written of nitrogen in here. Hence, we're gonna find the number, the or the mass, to find the molar mass of nitrogen with the number. We have to multiply molar mass with the total number of atoms, divide them with the total molar mass of the whole atom, and after that multiply with the 100, because our result will be at rate. Here, out the total amount or total percent of ammonia and nitrogen, we have just done here is put the molecular mass, or we have put the mass of a nitrogen here 40, and multiplied with the total amount of nitrogen, or total number of atoms or nitrogen atoms are present in that molecule, and then divide with the whole molecular mass. The end we just multiply with 100 to get the percent result. We just find out that nitrogen has 82%, and in the same way we find out the percentage of hydrogen, which is 18%. The two makes full 100%. So the result is given, you can see here. And last type of math we can see here is that finding the accurate relative mass. This type of math only comes with the isotopes or those type of thing, iso category type of math, where only you'll be given, you have to just, if there is percentage, you have to just divide 100 and divide those, this percent, this one 100 as well here, multiplied with the formula accurate relative mass. Let's talk about periodic table. You can see in the periodic table there is 8 group. Group 1, 2, 3, there will be electron loss contiguously. That group 1 to 3 will see electron charge in electron. So inside that atom, opposite or the positive or atom is the major atom. Atom is larger than that. I was saying that I need to give you an example. Atom, nucleus, neutron, two proton here, upper side, two electron here. Okay. If I erase or take out one electron, see one electron present in this atom and two protons are present in this atom. In that case, probability is charge, the atomic charge will be positive. What happens? Positive term is vanished. We have two electron but one proton. In that case, electron is large, but proton is not. In this case, atom will be negatively charged. You can see group 1 to 3, they all loses electron. Losing electron means in those atoms, number of protons are larger than electrons, so those electrons are positive charged, ionized. The four, number four actually don't react so much, that much. They both can gain 4 electrons or both can electron. From group 5 to 7, they start gaining ascending order. Group 7, atoms of group 7s are also known as halogen. Uh, all the atoms of all the halogen atoms has 7 electrons on their valence. Group 8 is known as neutral gas because their electron and proton number are quite same, or you can say they are stable electron. They do not react with any other gases. Another thing, this losing 1 electron, 2 electron, 3 electron, all those electrons are valence electrons. In an atom, or you can say there are two shells. The outermost shell is known as valence shell. The electron of these cell can atmosphere, but inside atom, atoms are polar or electron. They don't move easily. This electron moves from the atom. Talk about the electron configuration. So configuration is the way which electrons are arranged in various orbit atom. So here in the time I have said that it moves around the nucleus, but is an order. Some suborbits routine or they round in. So to get that arranged formation, we have a formula which is called SPDF. Here PFR for subshell shape or orbital shape of S is shape and the P is dumbbell shape. S can contains orbit or it maximum can 2 electrons. You can take the electron take up 40 electrons. Here you can see the what is in form 2s, 2p, 3s, 3p, 4s, 3d. In this thing that I want to share with you guys, electron configuration has 3 laws. Using those 3 laws, you can electron configuration. Those laws are principle and Pauli expression. According to Aufbau principle, it occupy the orbital of the lowest energy first. Fill the lowest orbital first, then go for the larger one. Another is Hund's principle. The most stable arrangement of electron is subshell 1, greatest number of spins. Three rules are must maintained to make the electron configuration. So here is a configuration you can see of oxygen where one square 12 electron configuration on at the bottom of this diagram. This is known as orbital diagram. As orbit has one box or one orbit and 3 orbits, and F has 7 boxes or 7 orbits. The arrows you can see all Aufbau principle. At first, the S orbit will be filled up, then then F orbit. Series way, filling process will be done according to principle. The electron which upward one positive spin. The first whole box opposite spin means negative floated inside the atom. This is the way you have to make the orbital diagram as the electron configuration. Configuration also another thing we have to make to mention that after 1s2 here 2 or this n number of electron that orbit can has. S has maximum 2 electron that's represented 2 oxygen cell with 2 electrons there. 1s and 2s are the subset of it. Only 2 electrons in the second orbit S sub and p suborbit are present. In suborbit there are 2 electrons. In p suborbit there are 4 electrons present. So in those S and P, we can say that in the second shell we have total 6 electrons there. Now you can analyze the whole atom.